Level 1, the undergraduate researcher. You're in college, a biology major, studying chemistry and physics. You love science. You want to understand how things work, why things happen, the fundamental questions. You volunteer in a lab, Professor Chen's research group in molecular biology. You wash glassware. You prepare solutions. You organize equipment. Grunt work, but you're learning lab techniques, research methods, scientific thinking. You observe experiments. You ask questions. You begin to understand the process. In your senior year, you have your own project. A small project, but yours. You design experiments. You collect data. You analyze results. You're doing science. You present at an undergraduate research symposium, a poster presentation. You explain your work to professors, to peers. You answer questions. You defend your methods. You're being evaluated, and you're hooked. Research, discovery, the pursuit of knowledge. You apply to graduate school, PhD programs. You want to be a scientist. The graduate student. Level 2, the graduate student. You're accepted into a PhD program at a top university, stipend, $28,000 a year. You're a graduate student. You're poor, but you're pursuing your passion. Your first year is classes, exams, rotations. You rotate through labs. You're learning advanced topics, specialized techniques, cutting-edge research. You choose a lab, your thesis advisor, Dr. Martinez, an established researcher, tough but fair. You join his group. You begin your dissertation research. This will be your life for 5 years. Your project is a novel protein with an unknown function. You must figure it out. You design experiments, hypothesis-driven, test, analyze, repeat, over and over. Experiments fail constantly. Nothing works. Months of failed attempts. You troubleshoot. You optimize. You persist. This is research. This is science. Finally, a result. A real result. Reproducible. Significant. You're elated. You discovered something new, something no one knew before. You work 80 hours a week, nights, weekends. Experiments don't stop, can't stop. You're in the lab always. Your friends have lives. You have science. You write your dissertation, 200 pages, 5 years of work condensed. You defend, oral defense, committee questions. You answer. You pass. You're a doctor now, PhD, doctor of philosophy. You're 30 years old. You've sacrificed everything, relationships, money, time, for this, for science. The postdoctoral researcher. Level 3, the postdoctoral researcher. You're a postdoc, a postdoctoral fellow. More training, more research. You join a prestigious lab, Stanford, MIT, Harvard, top institution, top scientist. You make $45,000 a year after a PhD, still poor, still struggling. This is the path. This is how you become a scientist, a researcher, a professor. You work independently now. Your own projects, your own ideas. You design, you execute, you publish. You build your reputation. Publishing is the currency of science. Papers in journals, high-impact journals, Nature, Science, Cell. That's the goal. That's success. You submit a paper to Nature. Months of work, years really, condensed into 6 pages. Rejection. Reviewer comments, harsh, critical. Your work isn't good enough. You resubmit elsewhere. Another journal. Revisions requested, major revisions. More experiments. You do them. 6 more months. You resubmit. Acceptance. Finally published. This is the grind. Write grants, do experiments, publish papers, repeat. Grant rejections, paper rejections, constant rejection. Thick skin required. You apply for faculty positions, tenure track, assistant professor, your dream. Hundreds of applicants for one position. The competition is brutal, insane. You get interviews, campus visits, job talks. You present your research. You meet faculty. You teach a class. You're evaluated on everything. You receive an offer, assistant professor at a state university. Not Harvard, but it's yours. You're going to be a professor, a scientist. Finally, after 10 years of training, Level 4, the assistant professor. You start your lab, your research group, your first students. You have startup funds, $500,000, to equip your lab, buy instruments, hire people. You recruit graduate students, undergraduates, a technician. You build your team. You mentor. You train. You guide. You're not just a scientist, you're a leader. But you must publish. You must get grants. You must prove yourself. Tenure clock, 6 years. Publish or perish, literal. Your career depends on it. You write grants constantly, NIH, NSF, DOE, foundations. Funding is everything. Without funding, no research, no students, no lab, no career. Your first grant rejected. Your second rejected. Your third rejected. You're running out of startup, running out of time. Panic sets in. Your fourth grant is funded. NIH, gold standard, $500,000 over 5 years. You can breathe for now. Your lab is secure for now. You teach undergraduate courses, graduate seminars. You prepare lectures, grade exams. You love teaching, but it takes time away from research, away from the lab. You publish papers, good papers, decent journals, but not enough, not high impact enough. You need nature. You need science. You need big discoveries for tenure. You work constantly, research, teaching, service, committees, administration. 60 hours, 70 hours, 80 hours every week. No breaks, no vacation. Year 5, tenure review approaching. You assemble your dossier, publications, grants, teaching evaluations, service, everything documented. External reviewers, experts in your field, evaluate you, your work, your impact. Department vote, college vote, university vote. Every level scrutinized. You get tenure, associate professor, job security for life. You made it. But you're 40 years old. You're exhausted. You've given everything. Level 5, the associate professor. Tenured, secure, but not done. You keep going. You keep pushing. You expand your lab, more students, more projects, more ambition. You pursue bigger questions, more significant problems. High risk, high reward. You're established now. You can take risks. You can think big. You collaborate with other labs, other departments, other institutions. Science is collaborative. No one works alone anymore. It's too complex. You mentor junior faculty. You remember being an assistant professor, the stress, the fear. You help them, guide them, support them, pay it forward. You serve on editorial boards, peer review. You evaluate others' work. You're a gatekeeper now of scientific knowledge, of publications. You attend conferences, international. You present. You network. You recruit. You're recognized in your field. People know your work, respect your contributions. But funding is always a problem. Always competitive. You write more grants. Some funded, some not. You adapt. You pivot. You survive. You think about promotion, full professor, the highest rank, recognition, honor. But it's not guaranteed, not automatic. You must earn it again. Level 6, the full professor. Promoted to full professor. 20 years in academia, 20 years of research. You've published hundreds of papers, trained dozens of students, secured millions in funding. You're a leader in your field. Your opinion matters. Your voice carries weight. You're invited to speak. Keynotes, plenary lectures, Gordon conferences, prestigious venues. You shape the field through your research, through your students, through your influence. Your former students are professors now at major universities, your scientific lineage. You take on administrative roles, department chair, center director, leadership positions. You manage budgets, faculty, programs. You're not just doing science. You're running things. But this takes time away from research, away from the bench, away from discovery. You don't do experiments anymore. Your students do. You think, you direct, you write. You miss the lab, the hands-on work, the direct discovery. But this is the progression, the trajectory, management, leadership, influence. You're elected to societies, national academies, fellowships, recognition, honor. Your peers acknowledge your contributions, your impact, your career. Level 7, the Distinguished Professor. Special title, Distinguished Professor, Endowed Chair, Named Professorship. You hold the John Smith Chair of Biology. Prestige, recognition, history. You're sought after by other universities, offers, packages, recruitment. They want you, your reputation, your grants, your students, your prestige. You stay, loyalty, or you leave, opportunity. Either way, you're valued highly. Your salary, $200,000, $300,000, maybe more. You've made it. You receive awards, major awards, National Medal of Science, Breakthrough Prize. Recognition beyond your field, national, international, media attention. You advise government, industry, policy. Your expertise matters to the world. NIH study sections, FDA panels, White House committees. Impact beyond academia. Your research is still groundbreaking, still innovative after 30 years. You're not slowing down. You're accelerating. Peak performance, peak influence. But you're 60 years old. How much longer? 5 years? 10 years? Retirement looms. You don't want to stop. Science is your life, your identity, your purpose. Level 8, the Nobel Laureate. The call, early morning, Stockholm, the Nobel Committee. You've won the Nobel Prize, in chemistry, in physiology or medicine, in physics. The pinnacle of scientific achievement, the highest honor in all of science. Your life's work recognized, validated, immortalized. The ceremony, Stockholm, December, the king, the medal, the diploma, the prize, $1 million. But that's not why. It's the recognition, the validation, the legacy. Your discovery decades ago, revolutionary, changed the field, changed medicine, changed lives. CRISPR, immunotherapy, graphene, whatever it was, it mattered. It changed everything. But here's the truth, the secret. The Nobel Prize is for old work. Your best work was 20 years ago, 30 years ago. The lag is real. You're celebrated globally, media, interviews, documentaries, fame. But you're 70 years old. Your best science is behind you. This honors the past. You continue. Of course, you don't stop. Your lab is still active, still productive. But you know the peak was decades ago. You're coasting on reputation, on legacy. You mentor the next generation. You share wisdom, experience, perspective. You've seen it all, successes, failures, breakthroughs, dead ends. You guide others. The Level 9, the Emeritus Professor. Retired. Professor Emeritus. Retired but honored, still affiliated. You have an office still. Library privileges. You're still part of it. But you don't run a lab, no students, no grants, no papers. You're free. For the first time in 50 years, free from the grind. You write a memoir, a textbook, perspective pieces, reflecting, synthesizing. You give talks, public lectures, science communication, sharing knowledge, inspiring others. You consult, biotech, pharma, startups. Your expertise still valuable, still marketable. Or you don't. You garden, you travel, you finally live without science consuming everything. You think about your legacy. Your students, 50 PhD students, they are professors, scientists, leaders. They train students who train students. Your scientific family tree, hundreds of scientists. Your papers, 800 publications, cited thousands of times, foundational work. Your discoveries in textbooks, in medicines, in technologies. You changed the world. But you also sacrificed relationships, family, health, time. You missed birthdays, anniversaries, vacations, moments, for experiments, for data, for science. Was it worth it? You discovered truths about nature, about reality, about existence. You added to human knowledge permanently. That's immortality of a sort. And somewhere, an undergraduate is volunteering in a lab, washing glassware, preparing solutions, excited, curious, in love with science. They have no idea what's ahead, the grind, the rejection, the sacrifice, but also the discovery, the insight, the contribution, the legacy. They'll learn step by step, experiment by experiment, paper by paper. The path is long. The path is hard. The path is brutal.